Okay, I'm going to go over how to do question 3 and question 10 from the study guide. Question 3, part A, is to simplify 1 over cotangent squared of x plus 1. So the first thing I think when I look at this is I know that all the squared trig functions have Pythagorean identities. So there's 3 Pythagorean identities, and one of them uses sine squared and cosine squared. One of them uses secant squared and tangent squared, and the other one uses cotangent squared and cosecant squared. So at this point, I would look up the Pythagorean identity that uses cotangent squared. Okay, and when you look at your reference sheet, you see that the identity, it says that 1 plus cotangent squared of u is cosecant squared of u. So we can take this cotangent squared plus 1 and replace it with cosecant squared. So this first step would be that this is 1 over cosecant squared of u. Okay, now 1 over cosecant is sine, right? We know that from the reciprocal identities. So that also works squared, because 1 over cosecant squared of x is 1 over cosecant times 1 over cosecant. So that's sine times sine. So this is sine squared of x, and that would be as simplified as you would want to get it, because it's just in terms of one trig function and it's not a fraction anymore. Okay, so that's part A. We use Pythagorean and then reciprocal identities. Okay, on to part B. Part B, you do have the option of using Pythagorean identity again. You might think that that might work for this. But actually, since this numerator and denominator already each have secant in them, we probably don't want to change it to a different trig identity. So instead, I would say I would then notice that this factors. This is difference of squared. Anything a squared minus b squared factors into a minus b times a plus b. And looking ahead, you can see that you're going to factor it into 2 terms, one of which is the same as the denominator that we already have. So let's factor this into the secant of x minus 1 times the secant of x plus 1. And then the denominator is just secant of x plus 1. So this entire term can cancel, and your final answer will be the secant of x minus 1. Make sense? All right, on to C. Again, you look at this and you're like, well, there's squared stuff, so I might want to use Pythagorean, but also it factors. You might be able to do it either way, but let's start by trying by factoring. It might get us somewhere. If not, we'll start over and maybe we'll try Pythagorean instead. But I know that the numerator factors again into a squared minus b squared, turning into a minus b times a plus b. Right? And then the denominator, both of those terms have a sign in it. So let's pull sign out to the front. And then we're left over with a sign in the first term and just a cosine in the second term, right? So that was just factoring with greatest common factor. Now I see that I have a perfect match here, so those can cancel. So now I have the sine of A plus the cosine of A all over the sine of A. Now, here, division distributes into addition, so I can sort of split this up into 2 terms with addition in between it. So this is the sine of A over the sine of A plus the cosine of A over the sine of A. And then we can cancel here into a 1. So the answer is 1 plus cosine over sine is cotangent of A. And that would be the simplest way to show the answer. Okay? All right, next problem, cosine of x times tangent squared of x plus 1. Here, tangent squared of x plus 1, it might help us to use Pythagorean, so we'll try that first. If that doesn't work, maybe we'll distribute through and see what happens. But I right away think when I see tangent squared plus 1, I know there's a Pythagorean identity for that, and that Pythagorean is that is equal to secant squared. So first thing I'm going to do is I'm going to write this as cosine of x times secant squared of x. Okay, and then secant squared of x is 1 over cosine squared of x. So But maybe I'll just turn one of those into 1 over cosine and leave the other one as secant. Then I don't have to like turn it back at the end. So I like thought of this secant of x as secant of x times another secant of x, and then took this secant of x and turned it into 1 over cosine of x. Make sense? Okay, and then the cosine of x can cancel because we're multiplying and dividing by the same thing. So it's 1 times secant of x, which is just secant of x, and that'd be our answer. So you see that each time in all these problems, our goal is to get it into just one single trig function with no fractions. That's kind of like the ultimate goal that we want. I think there's one more. E. All right. So again, I think secant squared of x could be using the Pythagorean identity, but before I do that, if I do that, I notice that both of these terms have a cotangent in it. So the first thing I probably want to do is factor. So I'm going to pull a cotangent of x to the front, and that leaves me with secant squared of x for the first term and 1 for the second term. So I'm just pulling this and that out to the front. So now it's right here. Okay? And then secant squared minus 1, I can use the Pythagorean on that. It's kind of up to you how you want to think about that. The identity is that 1 plus tangent squared of any angle is the secant squared of the angle. So you could either just take this secant squared and replace it with 1 plus tangent squared. That's one way to do it. And then the ones could cancel, right? Or the other way you could have done it is you could just take this identity right here and subtract 1 from both sides of it to just get like another identity, which is that the secant squared of u minus 1 is equal to tangent squared. So that's another way you could have done it. But either way, you end up with cotangent of x times tangent squared of x, right? And then kind of like I did on the last problem, one of those tangents I want to write as 1 over cotangent, and the other one I'll just leave as tangent. And then just like in the last problem, I have something that cancels, so my final answer is the tangent of x. Okay? So that's how you simplify these really complicated trig expressions. You have like factoring, you have turning things into sine and cosine, you have splitting up squares, Pythagorean identities. You kind of use all of those. And there's more than one way to do most of these problems. So if you did it a different way, you could have still gotten the same answer. Okay, let's go to the other type. This already has an equal sign in it, right? This is a trig identity that you're needing to show. You're needing to like verify that it's true. So this is a proof. And what you cannot do is you can't like divide both sides by something, because that like fundamentally changes what you're trying to prove is equal to each other. So instead, we're going to like use the same sort of a technique as we were using on these first problems, except for we are just simplifying one side at a time. So let's ignore the right-hand side because this is already simplified. The left-hand side is definitely not simplified, right? So let's try to simplify it. I see a common factor, right? There's a sign in both of those. So let's factor first. Let's pull a sign out. That leaves us with sine squared for the first term and cosine squared for the second term, because just like I did earlier, this sign and one of these signs I pulled out, right? And then this should hopefully ring some alarm bells in your head as something very famous. Sine squared plus cosine squared equals 1. So we can replace that with 1 with the Pythagorean identity. So that sine of theta. And now, see, now we're done because we started with the left-hand side, we simplified the left-hand side, and then we simplified again, and we ended up with the right-hand side. So we showed that the left-hand side and the right-hand side are equal, so we've proven it. So you can put a check mark by it, or you can put a little box with a like filled-in box that's like a math symbol for it has been proven, or you could write QED for it has been proven. Okay? All right, last couple problems. Here we're trying to prove that the tangent squared times 1 minus the cosecant squared is negative 1. Again, we've got like a lot of different ways to do this, but maybe I'll start by using Pythagorean like I did on an earlier problem. It's sort of already in factored form, so we don't want to distribute it back out, but cosecant squared, the identity is that cosecant squared is 1 plus cotangent squared. Right? So let's substitute it in. So the left-hand side is the same thing as tangent squared times 1 minus 1 plus cotangent squared. Then we can distribute the minus sign through. That's 1 minus 1 minus cotangent squared. Of course, 1 minus 1 cancels to 0, so we get the tangent squared of x times the negative cotangent squared of x. And then tangent squared, that's negative 1 over tangent squared. I just moved the cotangent squared and used the reciprocal identity. And then the tangent squareds cancel, and you get negative 1. So just like in the last problem, we started with the left-hand side, we simplified, 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 and ended up with the right-hand side. So we're done, QED. Okay, last problem. Now this one's a fraction already, and it's not like we can't find a common denominator and add it because it's already one single fraction. So there's really nothing easy to do here. So when in like your last resort, what you should do if nothing else seems like it would make sense to do, like there's no common factors, there's nothing right now. The only other thing we could do is we could put everything in terms of sine and cosine. Oops. So use the reciprocal identity here. Cosecant is 1 over sine. Cotangent is cosine over sine. And cosine is already in terms of sine or cosine, right? And now we have a complex fraction. See how we've got like fractions inside of fractions? And so look at the fractions inside of fractions, and the denominator is sine of x. So that means if we multiply all the way through by sine of x everywhere, top and bottom, so that we maintain equality, then it will clear out the denominators inside of this fraction. So you have to distribute it into each term, of course. So the sine of x times 1 is sine of x, and then sine of x times 1 over sine of x is just 1. And the denominator, looking at that first term, cosine of x over sine of x times sine of x is just cosine of x. And then cosine of x times sine of x is just cosine of x times sine of x. Can't simplify that from there. Okay, let's see, what can we do next? The numerator is definitely not possible to change right now, so let's just look at the denominator. See, now we have a common factor. We have a cosine of x in both that we can pull out to the front. This will be cosine of x times 1 plus the sine of x. Well, that's great for us because now we have a match that we can cancel. Sine of x plus 1 and 1 plus sine of x are exactly equal to each other, so we can cancel and we get 1 over the cosine of x. Well, that's great because that's secant of x, and if you remember, that was what we were trying to show. So we started with the left-hand side, simplified, 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 and ended up with the right-hand side, so we're all done. Okay, I hope that makes sense. These are like the trickiest types of problems from this whole chapter, in my opinion, because there's so many different types of algebra strategies you have to use. So if you're stuck, try factoring, try finding common denominators, try clearing the denominators if it's a complex fraction. Try using Pythagorean identities or reciprocal identities. And when all else fails, put everything in terms of sine and cosine. Sometimes that can make it look a lot more complicated, but then it can open up some other possibilities of like using these other strategies if you're sort of at a dead end. Okay, great. Please email me anytime with questions. And I can make more videos of certain problems from the study guide if you want me to, or I can just answer your questions over email. Thank you.